Hey students, in this video I'm going to go over the review for Unit 2A. We're going to go over the examples on the left side of the review, that way you can practice the ones on the right side. Okay, so the first one is asking you to identify the key attributes, and they give you the graph. So AOS stands for axis of symmetry, which is a line that is a vertical line, so something like this. And you need to just find where to place it. So the axis of symmetry goes here. It splits the graph in half, and your job is to write it as an equation. So vertical lines is specifying where is that placed on the x-axis, so x equals 4. Let me focus this for you. There you go. So x equals 4 is the answer for axis of symmetry. Then you have the vertex. Vertex is the corner of the graph right here, the turning point. And you just write it as an x comma y. So x value is 4, y value is 5, 4, 5. And the axis of symmetry and the vertex always are together. Therefore, the x value of the vertex is the value for the axis of symmetry. The max or min is you identifying if this point is considered a maximum or a minimum. So it is a maximum. Maximum is when you have the highest point and the graph goes down after that. Minimum is when you are approaching a turning point and then you go back up. So just keep that in mind for future examples. The domain and range is you identifying what are the x values and y values that are being used in this graph. Domain is for the x values, range is for the y values. So in class, I trained you to kind of make some annotations for yourself. Domain is left to right, range is up and down. And you're looking at a domain from side to side, going left, going right. This graph is going left and it's never stopping, and it's going right and never stopping. So if it keeps going to the left, you're going to end up with negative infinity as approaching negative infinity, but never stopping anywhere. Same thing over here, it's approaching positive infinity, but never stopping as well. So one of the notations for domain is the set builder notation, which represents all the x values are being used. So it's braces x, line that represents such that x is an element of all real numbers. So that's a set builder notation. And you have the interval notation, which will always follow the template of a minimum, comma, maximum. So if you're doing domain, minimum is to the left, maximum is to the right. If you're doing range, minimum is down, maximum is up. So just keep that in mind that this is for domain and this is for range. So for this case, we're going to have a minimum going to the left of negative infinity and a maximum of positive infinity, parentheses on both ends. So that's the interval notation. For the range, again, we're looking at it up and down. And now you need to identify that the max is on top and the minimum on the bottom. So this graph is opening down, which means it's going to go down forever. And if you go down forever, you're going to go down the y-axis forever to negative infinity. So your minimum for this graph will be negative infinity. And the maximum for this graph will be that turning point, the vertex. So that turning point is when y is 5. So looking at up and down, like an elevator, you go down forever to negative infinity and you go up all the way to 5 because of that vertex. So because your minimum is negative infinity and your maximum is 5, we can write interval notation with a minimum of negative infinity and a maximum of 5. We put a parentheses around the infinity sign and then a bracket around the 5. So for set builder notation, we're going to write the braces y such that y, and you just have to decide whether you're going to write less than or greater than. If you have a maximum value, you're going to end up saying that you have values lower than that. If you have a minimum value, you're going to say you have values greater than that. So in this case, we have a maximum of 5, which means we have values less than or equal to 5. Okay, so hopefully that helps you try the problem on the right side. The next two questions are on the topic of transformations. Graphing helps for those of you who are visual. So I'm going to pull up the calculator right here. And graph the parent function. But you don't have to graph. You could just analyze each transformation. So we have this graph as the parent function. Let me just make it a little smaller for you. And then you have this graph given, and you have to describe what it does to the parent function. So individually, if you compare the before and after, you notice that you have a negative written in the front of the absolute value. You have a 4 written inside the absolute value in front of the x, and then you have a 7 being added to that x. So those are the three things that are happening. This negative is on the outside, so that's an A value because it's on the outside. This 4 is a B value because it's on the inside of the absolute value. And then this 7 is affected by the H because it's added or subtracted to the X. Outside of the absolute value is the K, but in this case, we don't have a K. So the three descriptions we're going to talk about is what is that negative doing outside as an A value? What is that 4 doing as a B value? And what is this plus 7 doing as an H value? So the rules are on your notes. If you look at the transformation notes, it tells you what each one will do. But I'm going to use a calculator to show you what each one will do. The negative on the outside, it's typing a negative. And then I'm just going to type the parent function again, just so you can see what the negative does. So it reflects the graph over the x-axis. So that's the first description that we're going to write right here. Reflects over x-axis. So that's what the negative A value does. Then you have the next transformation, which is at B as a 4. So I'm going to double click and put a 4 in there, just so you can see what that B value does. So look at what's going to happen. It makes it skinnier. Now, you need to look at your notes and remember that A describes vertical changes, transformations, stretch and compress, and B describes horizontal. So as soon as you recognize the B, you're going to write horizontal. And now you need to describe what happened horizontally. So this graph became skinnier, so that means you had to squeeze the parent function in. So you had to compress it. And then you gotta say by how much. So when you talk about the B value, you gotta say 1 over B. So 1 over 4 is by how much. The last thing is understanding what that plus 7 does. So I'm gonna double click this and now put that plus 7. And then now we can see that it moved left. So it just shifted left. And that 7 tells you that it shifted left 7. So shifted left 7 spaces. Okay, so horizontal compression by 1/4, reflect over the x, and left 7. All right, let's try one more problem. We have, again, an A value outside of the absolute value, a negative B inside the absolute value. There seems to be nothing added or subtracted inside the absolute value, so that means there's not going to be an H. And then there's a K at the end because it's being added or subtracted. So let's talk about what the 1/2 does. So let me double click this and show you that. It's an A value, so I'm going to type it outside of the absolute value. And this is what happens. So this 1/2, because it's an A value, it's going to be a description that starts with vertical. And you're either going to say stretch or compression. So in order for this to have become wider, that means it had to be like squashed down vertically. So that's a vertical compression. And by the number that you have there. So when it's an A value, you just gotta say by the number that you see. If it's a B value, you gotta say 1/B. So I'll just put it right here on the side so you understand that. Then another transformation here is that negative on the inside. So I'm going to now type a negative on the inside. And look what happens. Nothing changed. And the reason why nothing changed is because this graph did reflect, but it reflected over the x-axis. So it kind of just spiraled around and got into that same position. So reflected over y-axis. And that's that negative b value right there. The last thing is that -8 at the end. So I'm going to double click and put -8. And notice that it just went down. If you want to see it, you can go Windows, zoom, and zoom out, and it's there. You can also trace it so you can verify where it went. So if you go down, it's 0, -8, which just means it shifted down 8. Okay, so those are the 3 descriptions of these annotations or transformations. All right, the next problem is writing an equation from a graph, and we just need to look for the vertex of the graph, because that is your H and K, and those are the numbers that will replace those letters. And we need to find the A value, which is the rise over run of the graph, but we gotta look at it going on the right side, not the left side. So H and K is -4, -3. -4, -3. And then the rise over run seems to be rise 2, run 1. Rise 2, run 1. So 2 over 1, which simplifying that will equal 2. So your A value is 2. So if we follow this template, we're going to write g of x equals the A value, which is 2, absolute value x minus your h, which is minus -4. Close the absolute value. And then plus k. So plus k will be plus -3. But we're going to rewrite that. 2 absolute value of x, double negative means plus, and then plus negative means -3. So this is the correct simplified equation that matches that graph. You can always graph this to verify in your calculator and make sure that it's matching that vertex and that y-intercept if you want to analyze it. Okay, the next one is domain and range. We have a graph that is showing v upside down. So again, left and right, this graph is going to go left and right forever. So the set builder will be the same as the front. So braces x such that x is an element of all real numbers, and -infinity to +infinity. The range, though, it's going to change a little bit because now we have a maximum here in our vertex of 4. So you have a maximum and a minimum down here going down forever. That's -infinity. So the interval following the template of minimum comma maximum is -infinity, comma 4, bracket on 4, parentheses on -infinity. And then set builder is braces y such that y is lower than 4, so less than or equal to 4. So just practice that on the problem right here on the right side. The last part is you now reasoning through the situation. that you have an equation given, and it's asking you to identify the range for that. You can graph it in the calculator if you have one available. I'm just gonna delete all that. And I'm gonna type it here. So control, let's see, sorry. So the question is 2/3 absolute value, x minus 4, and then minus 1. So let's find the vertex. Yep, sorry. Let me take that off. So menu, trace, graph trace. Okay, vertex. All the way to 4, -1. So the vertex tells you what the minimum value is, which is at 4, -1. So -1 is the lowest, and then it just goes up forever. We can sketch that, and we could have seen that without graphing by just analyzing the a value being positive, opens up, and then using this h and k as your vertex. So we have 4, -1 as our vertex. So keep in mind that the lowest this graph goes is -1, and the maximum it goes is positive infinity because it goes up forever. And it's asking for range. So these values are the ones that will help you. So we can cross out A and D because that's not up and down. We have a -1 as a minimum. This is your minimum, this is your maximum. And if we're writing interval notation, it has to follow minimum comma maximum. So the minimum is -1, maximum is infinity, parentheses, bracket. So therefore the answer is B. Okay, so hopefully this video helps you understand the review.